Alrighty, this will be episode number 9 in our video series journey of going from a noob to a veteran ASM coder. Previously in episode 8, we finished off the thread of how to make your own cheat codes, where we actually made a real code, which was the position modifier online code, and I taught you guys how to do that. Obviously, after which you already watched episode 7, learning PowerPC assembly. So now you know how to make basic codes, you know some ASM instructions, you can do some things on your own. So let's say you make a few codes or so, some basic codes, but now you learn enough ASM to where you need to use more registers than what are related to the default instruction of a static memory address in your code view. So you can't just choose which registers you want to use. There's specific rules for each registers. And if you don't follow these rules, 1, your game could freeze, or 2, the code could be affecting some other aspects of the game that you don't know are affecting, or they may not appear to be affecting, and you won't know till maybe later. So it's really important to follow this so-called register safety guide. Alright, so let's check out the thread. Alright, so let's say you need some extra registers. Which ones do you choose first? Well, right off the bat, register 12 is super safe. I would give it a 99.9% safety rating. The reason people figure this out is that essentially when the developers coded MKW and it was put into a compiler, when the compiler put all this into PowerPC assembly instructions, certain instructions or certain registers are used for certain purposes, and basically because of these purposes, certain registers are free to use a lot of times, and they won't affect certain functions or aspects of the game. So register 12 is by far the most safe. This is the first register you want to use if you need an extra register. Okay, and what's next? What's after that if you have to use more than one register? Register 11, I would rank it 99%. So imagine register 11 is the little brother of register 12. So these registers, these two, you can do quite a bit with 2 backup registers, if you will, until you actually start getting into some more complex codes where you need more than 2 extra registers to do whatever you need to do in your code. So just remember, 11 and 12 are always good to go. So let's go back and let's talk about registers 0 and 3 through 10. You can use these registers, but it's recommended you restore their value. So let's say you have a default instruction that includes the use of register 3 and register 7. So you already have to use register 12 and 11, or for some reason you can't use them, and you want to use register 10. Let's pretend that during your breakpoint, where you're pause at in code view, register 10 equals 1. So when you're writing out your instructions in your source, do something like this at the end of your source, or right before the end, or somewhere in your source after you modify register 10. Put it back to the value of 1 as a just in case thing. Now keep in mind, register 0 and 3 through 10, when you're doing this method to restore their values, they might be a different value every time your memory address, that instruction in your the memory address of your code gets executed. So it could be a chance that a lot of times that address gets executed, let's say 90% of the time the value is 1 in register 10. But there's some odd cases where it can be 5. This can be a problem, okay? So to understand the safety of these registers, remember this. The higher the number, the more safe it is. So if you do run into a scenario where register 0 or 3 through 10 has a changing value every time your code's address gets called on or gets executed, register 10, you can use it like register 11 and 12. You can use it to where you don't have to restore its value. I guess you could give it a 99% ranking or lower, because register 10 isn't really used that much in the game or whatever. So right off the bat, you have 3 registers free to use essentially without backing them up, or essentially without restoring their values at all. Easy to understand. So if we were talking about in episode 7, I think it was, on the assembly tutorial, we mentioned briefly how register 0 equals odd register. That at times it will be read as the CPU, and in certain instructions it'll be read by the CPU as just 0, right? So keep that in mind. So if you are going to use register 0 in your source and you need it as an extra register and you're going to restore its value later at the end of your source, keep in mind when using register 0, if you're using it like in a store instruction or a loading instruction, and it's put as the source register in that instruction, it's going to be read as just 0. So keep that in mind, a little oddball for register 0. So just to recap really quick, you basically have 3 registers to use freely, 12, 11, and 10. So for beginner coders, it would be really hard pressed to see why would you need more than 3 extra registers unless you are doing something very complex or your code, your source is not optimized. So if you are finding yourself in a situation and you're still on basic codes and you need more than 3 registers, reevaluate how you're writing your source. Chances are it is not very optimized. And we'll cover optimization in a later episode. Okay, so we covered that. Registers 14 through 31, these are not safe. My recommendation is until you know what you're doing with less basic codes, do not touch these codes. Touch these registers. You will notice in older codes, like codes made in 2008, 2009, 2010, some code creators used these because no one knew about register ASM safety for Broadway at the time. They would use like register 14 or register 19 just because they noticed it had a value of 0. And for some reason, because it had a value of 0, they thought it was safe to use. So just because a value is 0 in a register doesn't mean it's not being used. That value of 0 can be just as important as when a value could be 1 or whenever it's not 0. So I don't know why people had that thought or whatnot, but do not use register 14 through 33. Okay. And also to you guys, registers 1, 2, and 13, super dangerous. These are used in complex functions of Broadway. Never use registers 1, 2, and 13. Now let's go over some nicknames of these registers. In Dolphin, register 1 might be designated SP. Stands for stack pointer. I'm not going to go into what a stack pointer is or what it does. Just understand that it may be listed as SP, so don't use SP register. R2 might be displayed as, fix that typo, RTOC, stands for Register Table of Contents. Never use R2 under any circumstances. And R13. These are all no-goes. Okay? Now, there's a little tip in here. In the code view, let's go ahead and just launch the game really quick. And let's just pause it. And let's see if we can find something I can show you. Let me see if I can get something different. No, it's being a pain. Give me a second, guys. Might have to just write a list of codes instead of showing you a list of instructions instead of showing you an actual real example. Yeah, let's just do a example. So let's say you're at your code view and you have this. Let me close Dolphin really quick. Okay, and you have this, okay? This instruction. Okay, so you want to do some things with this. You know you can use 11 and 12 as backup registers if you need to use them instead of just manipulating register 4, for example. And you can also use, and you already you have to use more than just the you have to use more than just register 11 and 12, or also 10. So what do we do? And we need more registers, and I told you you can't use 14 through 31, and you can't use 1, 2, and 13. So essentially we call what's called looking ahead of your code address. Obviously in the code view, you're going to have instructions above your default instruction and instructions below your default instruction. generally speaking, instructions execute from top to bottom. So let's say you have this instruction right here. Now you guys will know from episode 7, the load word, any type of loading instruction, the destination register value gets wiped out. So what does this mean? Well, if this is our default instruction, and the next thing it executes is this, we know R3 is 100% safe to use. Because it doesn't matter what value we put in it, because once our ASM code gets executed, and this instruction gets executed, R30 gets wiped anyway. So you can use just looking ahead method to get you a few more free registers. And this is actually technically better to do than the R11 to 12, because obviously 100% is always better than 99%. So if you're writing instruction and you have one and you just need one extra register, I would actually recommend doing the R30 situation instead of just using R12 arbitrarily. R11 and 12 are just there because for ease of use and convenience. We know chances are they're always convenient. We don't have to go ahead and look ahead of our default instruction. We just plug in R11 and 12, we're good to go. But as I said, this is actually objectively better to do. Okay, so scrolling down a bit. Okay, so what happens if you still don't have enough free registers to use? Now, I did say before that you can never use R1. However, there is a complex list of instructions you can do that veteran ASM coders know about, which can get them free registers, which is safe to use. This is called push/pop the stack. Remember I told you SP stands for stack pointer? Well, we're going to be manipulating the use of R1. Okay, so if you need some free registers, this will get you a ton of free registers. So let me copy paste what you do here. You're just going to copy paste these instructions into your source. Do not modify them in any way, shape, or form. Might have to... you guys can read that. Yeah, that's fine. Let me blow this up really quick. Okay. So, what you're going to do is... Let me backspace that. This will allow you to use register 14 through 31 complete, like 100% freely. Or I should say 99%. This push/pop the stack method is about 99.9% safe. So about the same safety rating chances of using R12. I'm not going to go into details of how this could crash, but if this causes your code to crash, you got to find some other ways to get free registers if you already did the R11, 12, and looking beyond your code address type of deal. Okay, so where your default instruction resides varies. Remember I talked about in episode 8, and when you're making codes, no situation is ever going to be the same. So do not have this copy-paste mentality of I'm always going to put my default instruction here, or I'm always going to put it there, or my ASM contents are always going to be like this. Every situation is going to be different depending on what you want to do and what kind of code you want to make. So chances are, if it's a loading instruction, let me think about it. Honestly, it just really depends. But just understand that first, you're going to have these two instructions at the top of your source or near the top of your source. And you have these two instructions at the bottom of your source or near the bottom of your source. Now your actual ASM contents, what you want to manipulate in the game that does not include the default instruction, always goes in between these pair of instructions, always. So do that, and depending on what you want to do and what your default instruction is, whether it's a loading instruction or storing instruction, it's either going to be at the very top or at the very bottom. So this is what you would do, push/pop the stack method, to get you registers 14 through 31 freely. You could use this all the time if you don't want to deal with looking ahead of your code address or using R11 and 12, even though they are super safe to use. Keep in mind that this will make your code substantially longer. We are adding 4 instructions, so it could make your code 2 lines longer in compiled length. Some of you guys might not care about it, but a lot of people still use the classic method of applying cheat codes like on a GCT file on a console. They have a 256 code line limit they have to oblige by, so keep that in mind. But if you just want to use this for now as a beginner quite a bit, go ahead and use it. Okay, so I talked about the cons, just talked about the code length as a con, and it's still a 99.9% success rate. Floating point registers, I haven't really covered floating point registers, and you won't really be using them until you get to like an intermediate level, but I do list out their safety ratings just for you. Condition fields, which you have no idea what they are, do not be concerned about this until you are a very advanced coder, basically until you get to the very end of this long video series to the final episode. Will you ever worry about condition fields? So disregard this. Alright guys, and that's really the register safety rules and laws that you need to oblige by, or else you could cause the game to crash or do some unwanted actions in the game. So for episode 10, the next episode is going to be really important. It's going to be basic debugging and analysis of ASM codes. Alright, thanks for watching.